Essay 5.4 Tangent and Normal Line. So in this section, we will learn how to find the slope and equation of the tangent and normal line to a curve at a given point using the derivatives. So we all know that the derivative of a curve at a point tells us the slope of the tangent line to the curve at the point, and there are many different techniques for finding the derivatives of the different functions. So let's first talk about the tangent to a curve at a point. Okay, so section A, tangent process. Let's say we have a graph like this or curve like this, and let's say we have a point, and this point has coordinate x1 and y1. Okay, so we can say this is the point and it has coordinates of x1 and y1. Okay, so in this diagram we can state that our tangent line and the curve we have the same slope at the point x1 and y1. Means if I draw a tangent line that passes through the point x1 and y1, we can state that our tangent line and curve will have the same slope at the point x1, y1, and this means that around the point x1, y1, the line will only touch the curve once. Okay, so tangent line happens when this straight line touches the curve only once at the specific point. Okay, then the equation of the tangent line can be found using the value of the slope and the coordinates of a point which lies on that line, which is like I'm talking about the x1, y1 here. And from this statement, we also know that the tangent line and the curve both pass through the point x1, y1, right? So let's talk about why we are discussing this. Okay, so we already discussed how to find the slope at a point, right? However, the ultimate goal is finding the equation of the tangent line. Okay, so if you look at here, I have steps and the example, right? So let's say we have a curve f of x equals to 2x squared minus 6x plus 8, and there is a tangent line that meets this curve at point x equals 2. Okay, then to find the equation of the tangent line that meets this function at point x equals 2, we need to follow these 4 steps. Okay, so the first step is finding the y value when x equals 2. Okay, so we substitute 2 into that function, then we get 4, right? So when x equals 2, our y value is 4, okay? And this coordinate is for both function f of x and also for the tangent line, okay? Then second step is for differentiating that function f of x, okay? So we're going to find the derivative of the f of x by differentiating it. So we have 4x minus 6, right? Then we're going to use this derivative to find the m, which is the slope of the tangent line. Okay. Then to find the slope of the tangent line at point x equals 2, we need to substitute 2 into our derivative. Then we get 2. Okay. Then the slope of the tangent line is equal to 2. Then using this information, the coordinate 2, 4 and the slope equals 2, and the equation y minus y1 equals to m times x minus x1, we can calculate the equation of the tangent line, right? So we do y minus y1 is 4, and m is 2, x minus x, which is 2. Then we get y minus 4 equals 2x minus 4. So dy by y is equals to 2x, and this is our equation of the tangent line. Okay, then let's try some examples here. So example number 1, we need to find the equation of the tangent. So question A, I'm going to follow the steps, right? Step 1, we need to find our y value first. So we're going to substitute 2 into the equation, that we get -3 as our y value when x equals 2. Okay, then step 2, we need to differentiate the equation y, or the function y. Then we get 1 minus 4x. Okay, then step 3, we're going to find the slope of the tangent line by substituting the 2 into our derivative. Then we get 1 minus 4 times 2, which is equal to -7. Okay, then since we got all our coordinates, right, the coordinates and the slope, we can substitute this into our equation. Y minus y1 equals m times x minus x1. So we get y minus -3 equals to -7 times x minus 2. Then we get y plus 3 equals -7x plus 14. Then y is equal to -7x plus 11. This is our equation of the tangent line. Okay. Then I want you guys to stop this video and to try the remaining questions. Question B, question C, and D. Okay, then let's try the question B. I hope you guys tried this question already by yourself. Okay, so we have y equals 4 over square root x at point 1, 4. So step 1 is already done, right? We know the x point, that where the tangent line meets this function, and we know the y value, the corresponding y value to that x point, right? Then we're going to step 2, differentiate this function y. So we have 4 square root x, and this is same as 4 times x to the power of -1 over 2, right? Then we can differentiate this as 4 times -1 over 2 times x to the power of -1 over 2 minus 1. So we get -2 times x to the power of -3 over 2. This is our derivative, right? Then step 3, we need to find our slope by substituting 1 into our equation. Then we get y prime equals -2 times 1 to the power of -3 over 2. So we get -2 as our slope. Then we can now substitute these values that we just calculated into y minus y1 equals m times x minus x1, right? So we do y minus 4 equals m is -2, x minus 1. Then we get y minus 4 equals -2x plus 2. So y is equal to -2x plus 6. Okay, then let's try question C. I'm going to do it in the next page because we are out of space. So question C, we have a y equals square root 2x plus 1 at x equals 4. So we need to find the equation of the tangent to this function at x equals 4. So the first step is finding the complete coordinates, right? So we need to find our y value when x value is equal to 4. So we substitute 4 into the function y. Then we get square root 9, which is equal to 3. So we have found that when x value is equal to 4, we have y value equals to 3. Then step 2, we need to differentiate the function y to find the slope, right? So we have y equals square root 2x plus 1. This is actually equals to 2x plus 1 to power 1 over 2. Then you can see that we need to use the chain rule because we have a function inside a function, right? So the derivative of the function y is same as 1 over 2 times 2x plus 1 to power 1 over 2 minus 1 times 2. Then we get 1 over 2, 2x plus 1 minus 1 over 2 times 2. So the answer is 2x plus 1 to power negative 1 over 2. Okay? Then we have found the derivative of the function y. Then we can find the slope, which is the step 3. Right? The slope is same as when the same as the y value when x value is equal to 4, right? And we need to use the derivative to find the slope, right? So we do 2 times 4 plus 1 to the power of negative 1 over 2. And this is equal to 9 to the power of negative 1 over 2. And this is same as 1 over square root 9, so the slope is 1 over 3. Okay, then we have found out that the m value is equal to 1 over 3, and when x value is equal to 4, we have y value equal to 3. Then using the equation y minus y1 equals m times x minus x1, we can substitute all this value into this equation. Then we get y minus 3 equals 1 over 3 times x minus 4. Then we get our equation of the tangent as y equals 1 over 3 x plus 5 over 3. And we have calculated the equation of the tangent for function y equals square root 2x plus 1. Okay, then let's do question D. Okay, so we have function f of x equals x squared over 1 minus x at point 2 comma negative 4, and we need to find the equation of the tangent. Okay, so step 1 is already done for us, right? When x value is equal to 2, we have y value equals to negative 4, and it is given in the equation. Then step 2, we need to differentiate the function f of x to find the slope of the tangent line, right? So we do we have f of x equals to x squared over 1 minus x. So for this function, you can use quotient rule. So I'm going to set the numerator as a u and denominator as v. Then u is equal to x squared. U prime is same as 2x. V is equal to 1 minus x. B prime is equal to negative 1, right? Then using the quotient rule, I can find the derivative of the function f of x by doing v times u prime minus u times b prime over b squared, right? Then I do 1 minus x times 2x minus x squared times minus 1 over 1 minus x squared. Then we have found the derivative, right? We can also simplify this further into 2 minus 2x squared plus x squared over 1 minus x squared, and this is equal to 2x minus x squared over 1 minus x squared. Then using this derivative of the function f of x, so we can find the slope of the tangent line at point 2 comma negative 4, right? So slope is equals to 2 times 2, since x value is equal to 2, minus 2 square over 1 minus 2 square, then we can calculate the slope as 0, right? Then using the information slope equals 0, x value equals 2, y value equals to 4, and using equation y minus y1 equals m times x minus x1, we can calculate our equation of the tangent as y equals minus 4. Okay, then let's talk about the normal lines. Okay, so normal line to a curve is a straight line that passing through a given point but perpendicular to the tangent as shown in the diagram. So means when we have curve happening like this, and if we have a point here, so let's say this is our point x1, y1, we know that the tangent line happens when a straight line passes through this point and meets the curve at one point, right? So this is our tangent line. Then the normal line happens when another curve passes through this tangent line at the point x1, y1, but forms a 90-degree angle. Okay, then we know that this is normal line. So another purpose of the differentiating function is to find the normal line equation, or equation of the normal line. So we're going to talk about how to find the equation of the normal line. Okay, so we're going to still use the same equation, so we still going to use the same example as the tangent line. So we're still going to do f of x equals 2x squared minus 6x plus 8 at point x equals 2. Okay, so we're still going to use the same example. So we still have to do everything same. We start with finding the y value at this specific x value. Okay, so y value is equal to 4, and we still differentiate this function. So we do f prime x equals 4x minus 6. However, when you're finding the slope of the normal line, since we know that normal line is perpendicular to the tangent, we still have to find our slope of the tangent line. Okay, then call it m2. Okay, then we need to find our m1, which is the slope of the normal line. By using m1 times m2 equals -1, or simply we can say -1 over m2. So the slope of the normal line in this case is -1 over 2. Okay. Okay, then since we know that when x value is equal to 2, we know that y value is equal to 4, and also we know that the slope of the normal line is equal to -1 over 2, we can use the equation y minus y1 equals the slope of the normal line times x minus x1. Okay, then we do y minus 4 equals to -1 over 2 times x minus 2. Then we get the y equals to -1 over 2x plus 5, and this is the equation of the normal line. Then let's do example number 2. We need to find the equation of the normal line. So question A, the y is equal to 1 minus 2x over x squared at x equals 1. So let's do these questions in a new page. So example 2. Question A, we have y equals 1 minus 2x over x squared at x equals 1, right? So step 1 of the finding equation of the normal line is finding that missing y value. So we do y equals 1 minus 2 times 1 over 1 square, which is equal to 1 minus 2 over 1, and it's minus 1. Then we can conclude that when x value is equal to 1, the y value is equal to negative 1. Then step 2, we need to differentiate this function y. So y equals 1 minus 2x over x squared. So we have to use the quotient rule, and I'm going to set the numerator as u, denominator as v. Then u is equal to 1 minus 2x, u prime is equal to negative 2. V is x squared, v prime is same as 2x, right? Then using the quotient rule equation, we can find the derivative of y as v times u prime minus u times b prime over b squared. So we do x squared times minus 2 minus 1 minus 2x times 2x over x squared to the power 2. Okay, then we do we can simplify this equation. Then we get negative 2x squared minus 2x plus 4x squared over x to the power 2. Then this is same as 2x squared minus 2x over x squared to the power of 2. Then we can find the slope of the tangent line by substituting the 1 into our derivative. Then we do 2 times 1 squared minus 2 times 1 over 1 squared to power of 2. Then we get 2 minus 2 over 1, so it's equal to 0, right? So slope is 0. That means we also know that the slope for the normal line is equal to 0. Then we know the x value is equal to 1, y value is equal to negative 1, and then the slope is equal to 0. So okay, then using the line of the equation formula, so y minus y1 is equal to m times x minus x1, and using this information here, so we're going to substitute this information into this line of the equation. Then we get y minus 1 equals to 0 times x minus 1. Okay, then using the equation of the line, y minus y1 equals to m times x minus x1 with this information. So what we're doing is we're substituting this information into this equation. Then we get y minus 1 equals to 0 times x minus 1. Then we get y plus 1 equals 0. So the equation of the normal line is equals to y equals minus 1. Okay, then now we are trying to calculate the normal line for function y equals e to the power of negative x squared at point x equals to 1, right? So step 1 of the process is finding that missing y value when x equals to 1. So we need to substitute 1 into our equation y. Then we get our y value equals to e to the power of negative 1. Then step 2, we need to differentiate this equation. So function y is equal to e to the power of negative x squared. So if we set u equals to negative x squared, then our u prime is same as negative 2 times negative 2x. Then we can say the derivative of the function y is same as negative 2 times x times e to the power of negative x squared. Okay, then we can use this information to calculate the slope of the tangent. So the y value when x value is equal to 1 in this derivative function is equals to the slope of the tangent. So m is equal to negative 2 times 1 times e to the power of negative 1 squared. So it is equal to negative 2 times e to the power of negative 1. Then since we know the slope of tangent, slope of the normal line is equal to negative 1 over the slope of the tangent. So we do negative 1 over negative 2 times e to the power of negative 1, which is equal to 1 over 2 times e, right? Then using this information and the equation y minus y1 equals m times x minus x1 equation, we can say y minus e to the power of negative 1 equals to slope of the normal line times x minus 1. Then we say y minus e to the power of negative 1 is equal to 1 over 2 times e times x minus 1 over 2 times e. Then y is same as 1 over 2 e times x minus 1 over 2 e plus e to negative 1, or you can also write it as y equals e over 2x minus e over 2 plus 1 over e. Okay, and this is your equation of the normal line. Okay, then let's try the example number 3. So the curve y equals 2x cubed plus ax plus b has a tangent with gradient equals 10 at the point negative 2, 33. We need to find this unknown a and b. Okay, so since we have two unknowns, we need to set two equations to solve this question. So we're going to still follow the steps of the finding the tangent line, equation of the tangent line. Okay, so step 1 is already done. Okay, so we have found 33 is equal to the y value. 33 is equal to when x value is equal to negative 2, right? So we can substitute 33 and the negative 2 into the equation. Then we get following. Okay, then we can simplify it as a 33 equals to negative 16 minus 2a plus b. Then minus 2a plus b is equal to 49. So we got equation 1, right? Okay, then let's try the step 2. Okay, so step 2 was differentiating this equation, right? So even though we are not sure of the a and b, we can differentiate this equation y, or the function y. Then we get y prime is equal to 6 x to the power of 2 plus a, right? And then step 3 was the finding slope using this derivative. And then we know the slope is 10 already. So it means 10 is equal to 6x squared plus a when x value is equal to negative 2, right? Then substituting the negative 2 into this equation can get us to find the unknown a value, which is same as the minus 24 plus 10. So a value is negative 14, right? Then substituting this negative 14 back into equation 1 will help us to identify this unknown b value. So b value is equal to 49 minus 28, so it's equal to 21. So we have found both a and b value. So a is equal to negative 14, b value is equals to 21. Okay. Then let's try another example. This time I want you guys to stop the video and try this question first. Okay, I hope you guys have tried this question. So let's do this example number 4 together. So we know that the y equals 2x is the tangent line to the curve y equals x cubed plus ax plus b at x equals to 1. We need to find this unknown a and b. So we have two unknowns, means we need to set two equations to solve them. So we're still going to follow this process of the tangent line. So step 1, we need to find that missing y value, right? Since we only know the x value is equal to 1. So we're going to find the y value by substituting x equals 1 into the curve equation, the function, so 1 to the power of 3 plus a times 1 plus b. Then we know that the y value is equal to 1 plus a plus b. Then step 2, we need to differentiate this curve, right? So we get y prime equals 3x plus a. And we also know that this y prime is equal to the slope of the tangent line, right? So we know the equation of the tangent line is y equals 2x. Then from here, we know that slope is equal to 2. Then we can say 3x plus a is equal to slope and is equal to 2 when x value is equal to 1, right? Then we can say 3 times 1 plus a is equal to 2. Then a is equal to 2 minus 3. Then we know that a value is equal to negative 1. Then substituting a equals negative 1 into this first equation will give us the information y is equal to 1 minus 1 plus b, and then y is equal to b. Okay, then we need to find that b value, right? So the last step, it was like putting into the equation. So the equation is y minus y1 equals m times x minus x1. Then we know that y minus y1 is equal to 2 times x minus 1. Then we can say that our equation is y minus y1 equals 2x minus 2, and y is equal to 2x minus 2 plus y1, right? Then there's an issue. We know that from our calculation, our equation of tangent line is y equals 2x minus 2 plus y1. However, the equation of tangent that is given in the question is y equals 2x. That means we need to get rid of this minus 2 plus y1 so we can have a correct equation of the tangent line, right? So it means the negative 2 plus y1 needs to be equals to 0, right? So we can have y equals 2x as our final equation of the tangent line. That means the y1 value is equal to 2, and we know that y1 value is also equal to b value. So we can say b value is equal to 2. Then we have calculated that a value is equal to negative 1, b value is equal to 2.